All right, so good morning. This question is from the topic of law of conservation of linear momentum. Read the question first and then we will discuss. Okay, so here is the situation. You have a block which is moving with a velocity of v. Okay, so this is your velocity v. And then it collides with the second block. They, and note the keyword in the question. The keyword in the question is all the collisions are inelastic, right? So how is the collision happening? The first block goes and collides with the second block in an 100% inelastic collision. What happens? The two bodies club inside each other, right? So this clubbing, going inside each other and becoming one mass is a key characteristic of the inelastic collision, 100% inelastic. And then the combination of these two goes and strike this, so on and so forth. And this keeps on happening till the 500th block. You have to find the velocity of the 500th block. Okay, let's discuss how will we do that. I hope you have read the question, you understand the situation. Completely inelastic collision is your keyword here, right? Don't ignore that. Okay, let's go move on. Okay, I'll just reduce the size of the space to write. Okay, so let's talk about the first collision. Okay, now when the second body is hit, right, what do we write? M into V, which is the momentum of the first body. Now it is inelastic collision, 100%, and therefore it is 2m v dash. So v dash is the velocity when these two join, right? They become like a single mass, okay, for all practical purposes. They have joined, they become single mass, and they started moving with a velocity of v dash. Where to, right? Hit the next block. So v dash comes out to be v by 2. So this is v by 2 when it is a combination, right? So this is v by 2. Sorry, this is not v by 2. The combination is v by 2. Now this combination now moves to the third block and the second collision. The collision is second, but the block is third. Okay, so the combination of 2m, it is given that each block is identical. That makes my life very easy, right? So 2m into v by 2 is equal to 3m, because now 2m barges into the third mass, combine and become 3m, multiply by v double dash, right? So this m also goes away, 2 also goes away. So your velocity at the time of second collision here, this is your second collision. This was your first collision. The velocity of the combination at the second collision is v by 3. The velocity of this combination is v by 3. Right? Let's talk about the fourth one also. So if I write about the fourth one, the velocity with which the 3m is coming to hit the fourth one is v by 3. It will become 4m, and we have to figure out what is the velocity when the four masses are together. So this is going to be the third collision, but the clubbing of four masses, 1, 2, 3, 4, right? So let's see what happens. Okay, so this goes off. V dash is equal to v by 4. Now we can do this till 500, but there's no point. Let's use some logic now and see the emerging pattern as to what's happening, right? So your first mass was moving with velocity v. Your combination of first and second was moving with velocity v by 2. The combination of second and third and first was moving with velocity v by 3. The combination of first, second, third, fourth was moving with a velocity of v by 4. And when you reach the 500th block, when the combination of first to 500 is moving, what is going to be the velocity? No brainer, right? So the pattern tells me it should be V by 500. So all the masses have combined together. Why? For the simple reason, if it is V by 500 multiply by 500 m, I'm again able to get my momentum where I started from. Lesson learned. You could get rid of all the pain we took to justify the answer. The initial momentum should have been equal to the final momentum, right? I showed you to explain what's happening, but the initial momentum here is mv. Since there is no external force involved, and when all the masses combine at the last instant, the total mass is 500 m. And therefore, the velocity has to be v by 500 to make it mv as the final momentum. And hence, the momentum is conserved. So, I hope you enjoyed this question. Please don't forget to subscribe to my channel. Don't forget to miss on questions that are coming on the community tab. Be member of this community. You would see some fantastic questions, concept builders, and irrespective of the part of the globe you're in IB board, you're in Texel, you're Pearson, you are AP Physics, you're in India preparing for some uh, engineering entrance exam or board examination. This channel is out there to help you. The clarity emerges, the stress goes down, you start enjoying the subject, and then is when you score well, right? It is the clutter in your mind that needs to be removed. So watch all my videos and subscribe to this channel and do spread it. Thank you very much and wait for my next video.